Here's another way maybe to look at it is a design that Joe showed yesterday, which we have seen like binary values of saliency of a dot. Could be bright dot or dim dot or absence of a dot. And as a matter of fact, you see like it could look like end design if you ask your subjects, oh, as soon as you see both dots, press left one button. If you see only one dot, regardless of the brightness, press the other button. They will generate directly end design here, and you can use this is exactly factorial group. You can analyze it to calculate SAC function. So another way to look at the OR design again. Here's the case. I position now the target group over here. Ellipse position as a function of eye separation. We got all this saliency across different features. Here's a hero guy. You can make a decision maybe using this rule or that rule, or it doesn't matter which one do you use. So that's relatively easy to ask. Let me see what we found in the experiments in a study that we conducted. We find that SAC for these three particular subjects are all positive. All positive, which one it is. And can you recognize signature here? That's right, it's a parallel self-determining. So crossing there was parallel self-determining. And kind of we expected that. It's analytic in a way because we can stop on seeing one feature. You don't need to combine features. You only have to analyze single feature. So conclusion, parallel self-determining mental architecture. That's really holistic process. People can deal with it. How about the end case? Now this is a target group, the same thing here. Factorial, that's factorial manipulation, the two features, two saliency level high-low. What happens? We have to use both rules here to classify these guys. Or maybe we can use coactive rule too. Coactive mental architecture. In this case, I'm not sure really that we're dealing with simple rules as presented here. But you have to process both information. So here's what we found. What is it? 1, 2, 3. I can see this negative, the positive, negative, positive, negative, positive. It's not maybe visible clearly by eye, maybe from the distance that you're seeing. But this positive part is larger than the negative part. So that is signature. S signature, positive, larger than negative. And where does it find it here? It's not exemplary case, but we categorize it as a coactive because it shows the smaller negative part in the larger positive category here. So we say coactivity here. That's coactive processing. Interestingly, these subjects will report introspectively that they see faces after a while. They've been trained, to recognize these faces, and at the moment of test, they did like 20 sessions so far. So they showed really introspectively both coactive process. They saw entire faces and they indicated in behavior report, to see indicated behavior analysis. There's a coactive mental architecture. So this is these are the two cases. Another way maybe to look at the test is target category here, different faces, and we used similar design 2010 paper. These are the results for the 2010. So, how would I stay with time? 30 minutes to go. Please ask me any questions. I don't want to sleep and to be bored or something. I would like just to share some information with you, and then eventually, if you're wrong,
the way to analyze the RT data, you actually take all data, put a negative, in one pile as opposed to say you separate them into different segments. Is there any indication? If there's any indication that we change the processing as they?
The answer is very simple. You're saying, how do we get these distributions? And then use fixed size bins. And you know what? We use 10 milliseconds bins, but there's no difference. You're using 1 millisecond. Larger the bins, get coarser information, which is not good. So better maybe to use even 1 millisecond bin. Will generate nicely smooth function over there.
But the fact is, you put all the data together as one big packet, as opposed to say.
Yeah. So all these reaction times are belonging from only seeing this face here. This reaction time distribution is after recognition this particular phase here.
Is there a difference between like day one and day two?
Yeah.
Oh, day one, day two. Well, you can always monitor for that to see if there are any learning effects, and eventually, try to remove these learning effects if you're not happy with that, and try to also manipulate, in the analysis, to see whether there's any effect or not. Yeah. But you can do session by session. We did session by session. We didn't lump, if there's no big difference across sessions, then we just lump everything together.
In the example we're not discussing, the hero versus the end thing, you have only one example for the hero.
Yeah.
And then for the country that you member, you have.
Yeah.
So.
Yeah, it does make, in matter of fact, in this particular design, this member will show up, 4 times more than these guys, each individual case. But you know what, you can add 2 or 3 more guys and make another square here. There will be like 2 factorial designs. Sorry, two factorial designs. Yeah. So we have another design here, another design there. So it's about a matter of the point is whether you can generate enough of the differences on these eyes and lips position dimensions, or whatever your property you're manipulating.
Chinkar raised an interesting point, which is that in the OR task, is it possible that people are memorizing the hero face and then just checking whether any of the features mismatch the hero face, so they're not actually applying the rule boundaries in the manner that you think they are, but are instead just trying to confirm that one of the features mismatches, which might be amenable to parallel self-terminating process in a way which actually trying to use the boundaries in the AND task isn't.
I don't know. How do they? I don't understand. How would they compare?
So you have a template for the hero face.
Template for the hero face.
And then your task is just, does anything mismatch this hero face?
I would say, in this case, I would see not any of these recognizable signatures, but more something like coactive signature, because the template matching is not the same as a feature. It's a feature matching.
Oh, but the conditions that you're using to compute the SIC are not the template you memorized. So I see what you're saying.
Yeah.
So that you haven't memorized those.
Yeah.
You're just then processing. Well, does anything look different from the hero face? And that's something you can possibly do in parallel self-terminating fashion.
I don't see a really big difference by comparing the entire face that has one feature different than using comparing feature by feature.
The context though is that's something you can do in the OR task, so it's still in parallel self-terminating, but you can't do that in the AND task.
Yeah.
So that might be a reason why the AND task is too hard to do the parallel self-terminating.
Yeah.
Yeah, you have too many jets. You can't memorize them all. Or you could memorize them all, but it doesn't help you do the task.
Well, ideally would be to position another 3 guys here and then have them number of them balanced, so they don't go by. Next. And then the next step is, as I mentioned last time, there are many. I'm talking about different signature, holistic perception or configural perception. I mentioned a bunch of different ways we operationally define holistic processing for different types of effects observed in experiments, pop-out effect, particle paradigm effect, square effect, space inversion, unitization, chemophases. These are all different procedures leading to indication that underlying processing relies on holistic properties or configural properties. We see that Jim, Joe, and Daniel here mentioned super capacity that's in different forms they could use, and I talk about this co-activation signature. The question is, yes, so this particular experiment, when we use end research design as in particle paradigm, we show this superiority of recognition of features within the old phase context. You'll see like this is faster and then less accurate, at least with corresponding to this condition. But generally you see faster processing when you analyze this particular interaction time using SIC. We see there's a co-activation signature spread there, so it gives nice, interesting support. That something holistic is going on here. Then we publish this in a science paper. The question was, can we provide a validation, better, a stronger validation of such a signature? Yes, and I propose here, and together with Daniel, we propose dynamical SIC signature. So as we can probably before see, there's a catalog of the signatures of SIC signatures which are mainly static. Yeah, they don't change. They're just one frame of information captured across maybe sessions or experiments. But here we propose dynamical SIC signature. And the signature that I'm having in mind that will kind of adopt, snake wiggle, maybe for the time on more appropriate dragon wiggle or something like that. So what happens here is we can see that there's a SIC function, yes, SIC function that starts from this stage, yeah, it's negative at the beginning here, and you can see it starts to protruding and rearing, showing its head, above the line, at a certain point. So that's the signature we propose as another, should be maybe aligned together with a hall of fame of different operationalization of probabilistic processing. So, snake wiggle. I'd like to just give you one more maybe view of what's happening here. This simple, I don't know how do I get them. But anyway, the analysis was break down by sessions, session 1, 2, 3, 4, and the plenty of sessions. Subjects, as they're practicing this task that I just described, and task with the faces, at the beginning show this negative SIC function. Yeah, see? And we know from the catalog that indicates parallel exhaustive processing after session 7 and 8. But something started to happen afterwards, and the function started to change its shape. Still could be cataloged as a serial. Here, if you see, this is a or maybe even coactive here, negative part and positive part of approximately similar or very close similar areas. And then here's a negative one, some change of shape, positive, and ends up pretty much in positive. So what we see here is transition from negative function to function that is S-shaped, so mainly positive part. This is how it looks again. See how it starts to wiggle. If there's a form here.
The reaction time we've got here, is it an absolute value because 50 is very short, or is it a relative value to something else?
Time to stand. So this is a manipulation, right? In order to get this time stamp. So this is 2017. I'll show you the mean reaction time for this particular experiment. So it's extremely short. It's not like one of your super fast recognition experiments. This one is relatively slow. Yeah. So yeah.
So how many trials are there in which?
There are many trials in per session. Because we combined here 2 sessions. So there are at least 200 or maybe 300 trials for every one of the frame per condition. And there are 4 different conditions, as you remember, because it's two factorial experiment, 2 levels, 4 conditions. Yeah, there's plenty of trials here. It's pretty stable. The very interesting is that most of the subjects show similar change of shape. The dragon wiggle, is not only associated with the one subject presented here, but the other subjects will show similar transition. Now, there's another property that's worth paying attention is that you see like it starts from negative, then the area is around here, the total area of the SIC function is negative, and then if you progress into the practice, it becomes positive, and a pretty high R squared here, so this is a very trendy. So there's a one regularity here. Another thing that happens is if you look overall mean reaction time trend is going down, and errors too. Both reaction times are faster. So if you're going from the parallel exhaustive to what we believe is coactive, we see a speed up in processing recognition, and the errors are going down to the level of this is less than around 4 or 5%. So we have another indicator that subjects are speeding up that maybe that was previously used as a indicator of unitization. Unitization is similar effect that we used to indicate holistic processing, or maybe to indicate object perception, switching to a maybe better object perception for analytic, because what happens, you're speeding up in processing, probably because something is going on, you're more efficient, right? And it may be something unitized. In this case, the phase will be unitized. So that's another signature that's picking up. So here's a summary. This has a C function wiggles, from negative to actually positive function. All subjects wiggle. That is very interesting. Yes, all subjects wiggle in the same fashion. The final stage was coactive, and when tested later on, subjects showed this coactive signature. Some of them did not, but they stopped at certain intermediate point. There's a performance superiority, mean reaction time and accuracy both were improved, suggesting maybe kind of a unitization effect going on. Introspection also revealed the subjects are reporting seeing faces. Before that, in the first sessions, they were probably thinking, or maybe here, they're reporting, paying attention to features and using certain rules, and after a certain time, they're reporting, I start to see faces. Yeah, I just taped that on my MP3 player. Some of the subjects are just exactly very interesting report about that. So all in all, we say that the snake wiggling indicates, a holism. That is a holism that is built up, for maybe analytic type of processing. Can we learn more about it? So yeah, there is another indicator that could be used maybe to support the argument. There is a there is an increase in holism going on. Here, remember that before we pay attention to these target categories, here. But now additional analysis to be published in a paper with Daniel and Rafalsky indicated that these faces, we call them contrast group faces. Contrast group are exterior and interior faces. When comparing them, we can also indicate a change in their architecture as an additional argument, as a converging evidence. In matter of fact, this is what is predicted yet to be concluded. What certain conditions that reaction times when we compare exterior to interior, remember, will indicate serial model are exhaustive, they're equal, they will indicate parallel synchronizing model, they're coactive, indicate coactive processing. So comparing these two guys could also be used to another indicator of underlying processing. So what we're expecting to see in this particular case, as they progress to learning, they should be coming from here to here, from this particular mode, because we saw parallel exhaustive here, to the coactive one. And if you look at the evidence, this is exactly what happens. We find the difference between external phase minus internal phase. On average, we see that there's an increase in this difference, going to the positivity, to the indicator of the holistic, the coactive signature. And that when we average across all subjects, got a similar trend with a changing of maybe shape at certain points, but pretty much, copying, the same, showing that this increasing, all this monotonic increasing into coactivity, indicated but now different signature. So see this as a converging evidence to support the original conclusions. So how can we explain this snake wiggle? Yes, how can we explain? Well, we believe, there's in your mind, I believe each one of your minds or brain, maybe there's something like a machinery that can be used to amplify holism in a perception. I don't think it's really consciously regulated, but some other maybe system involved. What can happen is you can put yourself in analytic mode and start to pay attention to phase features. But you can maybe with a little bit of effort increase the amount of holism here, and then start to see glued features occasionally to the level where you can see entire faces. So I would say there is some mechanism that regulates this behavior, so we can start to pay attention to features, or we can also switch to features, to faces, whole faces if needed. So it comes better, if you're meeting with someone or discussing to see his whole face, not paying attention even to the nose and eyes and that kind of stuff. Maybe it will be also a tidy way, right? To see entire holistic person, not as a set of features. So this is a possible model parallel system, which we have a feature processor one, first feature, the second one is an accumulator of evidence. They get some information. When the information reaches threshold, it goes to the decision gate. The same thing happens with the same feature. So that will make parallel exhaustive system. But it's drawn in a more fancy way than before, right? You know, we have, I mean, it looks like a system for electrical engineers. Where does it come, where does it holism, comes in maybe a potential use of our system? It's, between crosstalks between these units. Now, these red lines indicate there's a crosstalk, so when you get some evidence from the facial feature 1, it's been sent, to the facial feature 2, and that, that speed up in accumulation of evidence, in the opposite feature. So if this is a well-learned phase, the two will help each other, and we can see this gluing, building from a parallel system to something that looks like coactive, positively facilitated mechanism. Here's the stuff that I propose, we harbor it somewhere in our brains, that you can actually turn left or right this knob and then change this level of cross channels facilitation between these two facial vision detectors. So again, let me summarize it. The last thing it is we propose is a snake wiggle dynamical signature of system factorial technology Ceval interaction contrast function that can indicate that through the learning there's a typical path to coming to holistic processing. So instead of providing freeze frame of current status of your processing, it shows you how that changes over time in a regular fashion. We see that signature is actually there's a converging evidence for that to believe actually that this change is transition from analytic to more holistic processing through superiority effect, the robustness it happens across many participants, maybe robustness in other processes. But in the introspection terms are also indicating that something is going on there. The entire stimulus set, wiggles, so it's not only one subject that we find. Most of them, show the typical change. The possible model here would be the model of the dynamic area simulation. Then we talk about this model actually in the previous paper. It comes very handy, to be used, to understand similar phenomena. And then let's wiggle, that's my final, so we can all around them. That will conclude, my presentations. If you have some questions, I'll be more than happy.
How does the capacity change as a function of practice?
I don't know that, but that would be good, maybe a follow-up experiment in which we would be able to track down what happens with the capacity of the learning of the trial sessions. I did some investigation some times ago, but I'm not sure, that I can pull this up, for this particular signature. Yes. I don't think we designed the experiment capacity function at the time, so we would really be, careful, to make the conclusion. But that would be a good follow-up experiment, maybe to do to test capacity. There will be maybe another converging evidence, for the entire thing. Yes.
In your example, the snake wheel example, am I right that the coagulation that takes like the average all your RT data on session 1 to session 8?
It's not the average, it's breaking down to different sessions. So the dynamical signatures is
Yeah.
that happens across learning sessions.
Yeah, but I mean, the conclusion, at the end,
Yes,
coagulation.
yes, that's my conclusion.
So I just wondered that there any constraint on the
history of the session. So the window part, and is there any property that in some conditions, it's impossible to get certain kind of sequence and then come out with the coagulation conclusion? There's some mathematical constraint.
I don't see any mathematical. We used to use the same set of assumptions that we use for the regular factorial experiments, except we add variable of a training or exposure to the task. So you can see through the learning what happens and how the signature changes of the learning. So I don't see any other constraint in it there.
So you mean this regularity, this pattern is always like that?
Yeah, that's what we found, across many participants, the patterns will change in the same fashion, from overly negative to mainly positive. Well, I have to say that some subjects, at least one, never reached positive, but, were somewhere around zero. So kind of halfway between. Maybe the subject did not develop any holistic processes and decided to stay within the area of analytic, which is still, manageable in this task. You can analyze these spaces using analytic techniques. But what if, you get certain kick later on and you start to using these holistic properties because you learn these spatial features, so it's getting much easier. You got this boost in processing. It's probably much easier doing the task.
Does it mean that in other stuff it's not the feature set, but other stuff is like this time when we get the co-activation process, the representation is always like.
I would say yes, because, for example, this effect of speeding up can be achieved in many ways. And speeding up and increasing accuracy across sessions can occur just because maybe your faster in processing, your overall rate increases without the change of the mental architecture. So maybe you're processing serial here, and maybe you're processing serial here, but this faster serial. We don't know that because this one doesn't tell you anything. It just tells you it speeds up. And speeding up can be achieved in many ways. Maybe here we are too cautious, or not too cautious, probably because there are too many errors, but maybe we couldn't see the features well, and maybe in a serial system, and maybe see features much better here, but we still process in serial. And if that is right, we should be able to see a serial signature here and a serial signature here, but this is not what we see. We see change, and we see the typical change in the machine. So that's why I say that's much better analysis, because it provides you more information what happens with the processes in terms of processing order, stopping rule, and dependency.
The dot patterns, for example?
I would like to use the dot patterns too, yeah.
Yes. So,
I didn't use it, before, but yeah, I would love to use it, yes.
more extensions, if like 3 features to 1 features, but or and will also have this kind of guessing.
In the essence, I believe yes. If you believe, if you develop in the holistic properties, then this is what should happen. Signature with the 2 features here, because we believe features here are equal the number of processes. With the 3 features, you have 3 different signatures. Now that's another story.
Yeah. Because that is the configuration of the different features, or just the one very basic mental processing for all tasks to back tasks.
We don't change, there's no change here in the type of logical rules used to process the task. You have to analyze these cases using AND rule in all cases. So, but that's good, because then with these changes, we do not explain by changing the logical rule. The only thing that can be used to explain these changes is actually change in the architecture, in the mental architecture. And what kind of change? Well, we provide, some converging evidence that it is actually coming from parallel to coactive. It doesn't switch actually in terms of the parallel to serial, or probably not, but we believe it's parallel from the beginning, and then it builds up, this facilitation between units. They will lead, to the change of the signature will go through first type to the coactive type, the parallel type, parallel exhaustive to the coactive type.
I'm sorry, we have to stop here. Last talk, we didn't like this. So possibly we have more efficiency, so we can do that. Sorry about that.
That's great, thank you.
So, no stop. Let's begin the math talk, given by